to fly without polluting the atmosphere. Engineers around the world are developing aircraft and fuels that will one day make this possible. The new technologies are needed more than ever. At high altitudes, emissions from conventional aircraft have a stronger greenhouse effect, 3 times stronger than on the ground.
We want to make it possible to fly climate neutrally in the future.
An initial production of climate-neutral fuels is already underway at a research institute in Karlsruhe, Germany, in completely new reactors. And at this airport, it will soon be possible to fly climate-friendly. We want to operate the airport and transport infrastructure climate-neutrally by 2030. We hope that by then the airlines here will gas up with as much climate-neutral fuel as possible when they take off and land. This is the airport in the southern German town of Memmingen. Over 2 million passengers to over 50 different destinations take off and land here annually. The demand for electricity and heat for ground operations alone is equivalent to that of a small town. The airport uses green energy to make the operation climate neutral. And there is an abundant amount of green energy in the immediate vicinity. Memmingen is located in the Allgäu region of Germany. It is a unique landscape with a great deal of biomass production in the form of grass, corn, and manure. Some of that ends up in a biogas plant. The engineers at the plant are able to utilize a significant advantage of this green energy. Plants are used to store energy at the biogas facility. We can feed it as needed into our heat and power plant in the form of biogas. This, of course, complements other renewable energies such as PV and wind, where we have a lot of during the summer and very little in the winter. So we can use the biogas more during the winter and less in summer. What is unusual about using biogas is that the gas itself is not burned on site. It flows via a 5-kilometer pipeline to what is known as a combined heat and power plant, or CHP, in the immediate vicinity of the airport. In this CHP, a large engine burns the climate-neutrally produced gas and drives a generator, which in turn produces electricity. At the same time, large amounts of waste heat are generated. The heat is managed. We use the energy in our district heating network when we really need it. This is where the heat goes in order to get the maximum effect and maximum efficiency. The plant is able to work so efficiently because biogas, for the most part, is produced when the demand for heat is particularly high. This means that the renewable energy stored in the biomass is used and fermented into gas, predominantly in winter. The climate-neutral gas flows via a pipeline to the biogas power plant, which produces the electricity and heat. And the bioenergy plant is located exactly where the energy is needed, in the immediate vicinity of the airport terminal and in the middle of an industrial park. The buildings can easily be supplied via a district heating network. Around 90% of the energy stored in the biomass is used in this way. Not far from the runway, there are also plans for a large photovoltaic system. This will produce a great deal of electricity, especially in the summer. Precisely when the biopower plant slows down due to the lower demand for heat, and therefore also produces less electricity. Several components of a climate-neutral energy supply are optimally combined in Memmingen. The system offers even more advantages. The engineers in Memmingen use a special management network to control the system. These heat storage units absorb the demand for the district heating network for approximately 12 hours. This means that green electricity can always be produced exactly when needed. This increases efficiency even further and also stabilizes the electricity grid. It is my feeling that in 5 or 10 years, there will no longer be any biogas plants that aren't able to create heat and electricity at the same time. Otherwise, it would make no sense. I think we have to reach an overall efficiency of 80 to 90%. And of course, this is only possible if heat and electricity are used at the same time. By using locally available renewable energies at its airport, operations on the ground in Memmingen will be completely climate neutral in just a few years. But airplanes will also have to take off in the future without emitting greenhouse gases. And they are also working on this at the airport in Memmingen. In my opinion, battery electric planes will soon be possible with smaller aircraft that fly within Germany. Planes that have up to 10 seats, 20, maybe even 30. But for anything greater than that, I think we're going to need hydrogen at the very least, or aviation fuel that was made like an e-fuel, meaning it was produced synthetically and is therefore CO2 neutral. To fly climate neutrally, airplanes can use electricity from wind power, solar, or biogas plants, and combine different technologies. So-called air cabs store electrical energy directly in a battery. This is quite efficient. The problem, however, is that battery-powered aircraft can only transport a few passengers, and the range is only a few hundred kilometers. But green electricity can also be used to produce hydrogen. This climate-neutral energy source can be used both to fuel aircraft and power purpose-built engines. But here too, the number of passengers and range are also limited when using green hydrogen. In order to cover longer distances, across the Atlantic, for example, airplanes will need to be supplied with fuels that have the same energy density as the fossil fuel kerosene. Fortunately, such climate-neutral liquid fuels with a high energy density can also be produced in special plants using green electricity. This is exactly what scientists at the Karlsruhe Institute of Technology are researching: how to produce these fuels efficiently in their own energy lab.
We want to make it possible to fly climate neutrally in the future. That is why it is necessary to produce synthetic fuels, and in this case, we're talking specifically about E-Kerosene.
E-Kerosene can be produced using green electricity and carbon dioxide from the atmosphere. If the E-Kerosene is burned in a turbine, the same amount of CO2 is produced as was previously extracted from the atmosphere. This makes its use climate neutral. What is important for the production of this fuel is what is known as synthesis gas.
Hydrogen and carbon monoxide are produced in this plant. Mixed together, they create what is known as synthesis gas. Synthesis gas can then be used to produce many different organic molecules in further steps of the process, such as energy-rich hydrocarbons, for example.
This plant uses water, carbon dioxide, and green electricity to produce energy-rich hydrocarbons. In a process known as high-temperature co-electrolysis, the water and carbon dioxide molecules first diffuse to a porous cathode. This takes place at around 800 degrees Celsius. Each water molecule takes up one electron. A negatively charged oxygen atom is formed. The molecule splits to form pure hydrogen and a negatively charged oxygen atom. This diffuses into the cathode. And the carbon dioxide molecules also take up electrons. Another negatively charged oxygen atom is formed. Carbon monoxide is also released. The oxygen atoms move through the electrolyte to the anode. Here they release their negative charge and neutral oxygen is produced, which escapes into the air. The hydrogen and carbon monoxide molecules produced at the cathode are the synthesis gas. And this gas flows through the pipes to another plant. A special reactor is located here. This works according to the so-called Fischer-Tropsch process, known to be exceedingly efficient. There are many microchannels in the reactor, and these channels in turn contain a metal powder that consists, for the most part, of cobalt. The hydrogen and carbon monoxide molecules flow over the powder. In doing so, it acts as a catalyst. This means that the carbon and hydrogen atoms combine on the surface of the powder. High-energy hydrocarbon chains are created. These molecular chains have different lengths. After the process, the scientists store the finished products in a warehouse. Since the molecules are of different lengths, they also have different states of aggregation.
Both the liquid fraction and the fraction that resembles wax are preliminary products that need to be further processed to produce E-Kerosene. And E-Kerosene can be used as a climate-neutral fuel.
The advantage of E-Kerosene is that the existing infrastructure can be used to refuel aircraft. The problem, however, is that in addition to green electricity and water, the production of E-Kerosene also requires a high concentration of carbon dioxide. And this is far more concentrated than in normal ambient air. To save energy in the process of creating highly concentrated CO2, the Memmingen engineers therefore want to use their biogas. Biogas basically contains CO2 and methane, and the biogas is currently burned completely in the CHP plant, generating electricity and heat. In the future, however, we can also filter out the CO2 contained in the biogas and use it for the production of renewable kerosene, for example. This is how the engineers envision things. The biogas flows towards the airport as before. There it is separated into methane and CO2. The methane continues to burn in the CHP plant. Electricity and heat are produced exactly as they had been. In addition, another energy source is to be produced on site. The electricity from the photovoltaic systems flows to an electrolyzer. This produces climate-neutral hydrogen with the help of green electricity. The hydrogen flows via a pipeline towards the airport. There, it supplies a filling station. Here, trucks can fill up with the climate-neutral fuel. The green hydrogen flows together with the CO2 obtained from the biogas to a specially built plant. In this plant, E-Kerosene is produced using a process similar to that in Karlsruhe. The biogas and solar power produced in Memmingen can be used to produce several different sources of energy on site. air cabs use climate-neutral electrical energy for short distances. In addition, tankers deliver the climate-neutral hydrogen to purpose-built aircraft. They can cover medium distances with this energy source. Large aircraft can also refuel with E-Kerosene at the airport for long distances. However, it is on these long-haul routes that most of the aircraft kilometers are flown. This means that green electricity and green hydrogen in the tank will only be able to replace part of the fossil fuel kerosene. Without E-Kerosene, aviation will not become climate neutral. But despite the efficient technologies, Memmingen will not be able to cover the demand for this fuel locally. I think that we can produce about 5% of kerosene locally, and the rest will have to be imported, just like conventional kerosene today. The problem is that a very large amount of electricity is required to produce E-Kerosene. To replace conventional fossil fuel kerosene in Germany, all the green electricity currently produced in Germany would have to be used for E-Kerosene production alone. This means that Memmingen Airport will not be the only one dependent on imports. Nevertheless, in-house production makes sense. Memmingen Airport can meet the first EU requirements for adding E-Kerosene from its own resources. In addition, other green energy sources will also be available in the future. Operations on the ground are already almost entirely climate neutral. This is much more than just a start. The Allgäu region of Germany is not only home to a unique landscape, but will also be home to innovative aircraft. And with Memmingen Airport, a significant pioneer in climate-neutral flying.